Hello, everyone. Welcome back. Today, we're going to be talking about the basics of triangles. So let's get into it. So there are two different ways, or two different main ways, I should say, to characterize triangles by sides and by angles. Let's start with by sides. A scalene triangle is a triangle that has sides that are all different lengths. An isosceles triangle has at least two congruent sides, meaning it has at least two sides that are the same length. The third side may also be the same length as well, or it may be different depending. And then the third one is an equilateral triangle, which means that all sides are congruent. So all three sides are the same length. We can also classify triangles by angles. An acute triangle is a triangle where all the angles are less than 90 degrees. They're all acute. A right triangle is a triangle that has exactly one right angle, so exactly one 90-degree angle, and both other angles are acute angles in this case. And then we have an obtuse triangle where exactly one angle is greater than 90 degrees. So, in other words, we have exactly one obtuse angle, and of course, our other angles are still acute. And so, triangles, or one way we can think of characterizing triangles by angles, is we characterize them by what is their largest angle. If their largest angle is acute, then it's an acute triangle. If the largest angle is a right angle, then it's a right triangle. And if the largest angle is an obtuse angle, then it's an obtuse triangle. So that's another way we can look at it is what is the largest angle? And then that angle is what characterizes what type of triangle it is. Because reality is every triangle is going to have at least two acute angles. So the question is, okay, is the third one, is it also acute? Is it right or is it obtuse? There's also the triangle angle sum theorem. And this is a very important theorem that we're going to use probably almost every single unit of geometry and beyond there. It's an extremely useful theorem. Even when we get into trigonometry and more challenging problems, we are still going to use this theorem. This theorem is pretty simple. It says that the sum of the measures of the interior angles of any triangle, regardless of the type of triangle it is 180 degrees. So if we add up measure of angle A plus measure of angle B plus measure of angle C, that is equal to 180 degrees. Example 1 asks, can a triangle have three interior measures of 90, 30, and 60 degrees? Well, let's see. If those three measures add up to 180, then yes. If they add up to any other number, then the answer is no. Now, luckily, 90 plus 60 plus 30 does equal to 180 degrees. So therefore, the answer is yes, that it is possible for a triangle to have 90, 30, and 60 as the numbers of degrees. Example 2 says to find measure of angle B. So the most useful, the general thing we're going to typically do with triangle angle sum theorem is sometimes, let's say we have the measures of two angles but not the third. We can use this to find the third. We can say, well, we know that all three of them, that 67, which is measure of angle A, plus measure of angle B, plus angle C, which is 30 degrees, is equal to 180. So that tells us, if we rearrange this, that measure of angle B is just 180 minus the other two angles. So all we have to do is just subtract the other two angles, and then we're good to go. And in this case, I'm getting 83 degrees. And so therefore, measure of angle B must be 83 degrees in order to make it so that all three of them add up to 180, which is something we know to be true of all triangles. Example 3 says to find measure of angle C. Now notice it might look on the surface like we only have one angle here, which is angle A, which is 55. But whenever you see this little square pattern on one of the angles, that automatically means, that little symbol there, means it's a right angle. And all right angles have a measure of 90 degrees. So therefore, we actually also know angle B. We know that angle B is 90 degrees. And so using that information, we can find measure of angle C. Measure of angle C is equal to 180 degrees minus 90 degrees minus 55 degrees, which is equal to 35 degrees. And so, therefore, measure of angle C is equal to 35 degrees. All right, well, that's all for the basics of triangles. We will be doing more triangle angle sum theorems where we find the missing angles of triangles using this theorem, but also using variables and more complex examples in the future.